Hey everyone, welcome back. I'm super excited to have you here today. We're about to embark on an awesome journey, exploring the fascinating world of ETL testing with Python. In our last session, we tackled some really important interview questions from a top-notch multinational company. And trust me, we're not stopping there. We've got a whole bunch of new interview questions headed our way. So if you're ready to dive into the world of coding adventures, hit that thumbs up button and make sure you're subscribed so you don't miss out on any of the action. Today, we're all about unraveling the mysteries of ETL testing, and I promise you it's going to be a lot of fun. All right, let's jump right in and get started. Happy coding, everyone! The first question is, write a Python function to remove duplicate elements from a list. All right, first understand the question, and then we will jump into the solution. In ETL, we often deal with large data sets, and data integrity is crucial. One common issue is having duplicate data. Imagine you're extracting data from a source, transforming it, and loading it into a target system. If duplicates are not removed, it can lead to inaccurate analysis and reporting. To demonstrate how Python can help us with this challenge, in Python we can eliminate duplicates in two ways. We can convert the given list into set data type, or we can write a function that removes duplicate elements from a list. First, we will write a function that removes duplicate elements from a list. Open up your favorite code editor and follow along, so let's dive right in. All right, the first thing we need to do is define a function that will take a list as input and return a new list with duplicates removed. Let's call it remove duplicates. We've just defined a function named remove duplicates that takes a single parameter, lst, which represents the list we want to remove duplicates from. Now, inside our function, we want to return a list that contains only the unique elements. We can achieve this by converting the list into a set, which automatically removes duplicates, and then converting it back to a list. Let's do that. Brilliant! We're returning a new list here. We're using the set function to create a set from our input list lost, and then converting it back to a list using list. This will remove all the duplicates. Now that our function is ready, let's test it out with an example. I'll create a list with some duplicate elements, and then we'll call our remove duplicates function to get the unique elements. Here, I've created a list called input list with a few duplicate numbers. Now, I'll call our remove duplicates function and pass in this list. The result will be stored in the unique list variable. Finally, let's print out the unique list to see the result. And there you have it. We've successfully removed the duplicate elements from our list. And another way to remove duplicates is, without creating a function, we can eliminate duplicates. Let's see how we can do that. Here I am using the same input list and commenting out function and other steps. We can achieve this by converting the list into a set, which automatically removes duplicates, and then converting it back to a list. Let's do that. We're using the set function to create a set from our input list, and then converting it back to a list using list function. This will remove all the duplicates, and the result will be stored in the same input list variable. Finally, let's print out the input list to see the result. And there you have it. We've successfully removed the duplicate elements from our list, so creating a function is not mandatory, but it is preferable. And that's it. Now we will jump into another question. And the other question they asked is, create a Python dictionary that maps names to ages, and then print the names of people who are above a certain age. All right, first understand the question. Imagine you have a list of people with their ages, and you want to find out who's older than a certain age. How do we do that? Well, that's what we're going to explore in this video. Now imagine you're the manager of a cool club, and you have a guest list with people's names and ages. You're curious to know who's above a certain age so you can plan some special events for them. But looking through the list manually is just too tedious. That's where Python comes to the rescue. Picture this like having a big notebook where you've written down everyone's name and age. In Python, we can do this with something called a dictionary. It's like a fancy address book that pairs names with ages. Let's set that up and... Now, you don't want to invite just anyone to your special event. You want people who are older than a certain age, right? So, let's decide on that age. For our example, we'll say 30 is our magic number, and this is where the real magic happens. Imagine you're flipping through your guest list and picking out only the names of people who are older than 30. In Python, we can do this using a special technique called list comprehension. It's like quickly making a new list from an existing list based on a rule. Here's how we do it. We create a variable called names above threshold, and the list comprehension technique. Name for name, the age. In people, items. If age is greater than age threshold. Ta-da! You've filtered out the names of the people who are above the age of 30. Now, it's time to reveal those names and give them the VIP treatment. Let's run this code. And reveal the name. And there you have it. With a dash of Python magic, we've created our guest list, set an age limit, filtered out the right names, and printed them out. This shows just how powerful and handy Python can be in solving real-world challenges. I hope this explanation made the concept crystal clear. If you enjoyed this, give that thumbs up button a click, and make sure to subscribe for more amazing Python adventures. Catch you in the next question. And the another question is, how would you read data from a CSV file using Python? Okay, we're going to see how to read data from a CSV file using Python. CSV stands for comma-separated values, and it's a common file format used to store tabular data like spreadsheets. Whether you're working on a data analysis project or just need to extract information from a CSV file, this will walk you through the process step by step. So let's dive right in. First, we need to import the CSV module, which provides functionality for working with CSV files. We do this by typing import module. This line tells Python that we want to use the functions and classes provided by the CSV module. Next, we'll open the CSV file using the open function. So to do that, we need to provide the file path as a string. Let's say our data.csv file is in the downloads directory. Here's how we do it. File path is equal to, and we need to provide the file path here. And we use a raw string, R, to avoid any issues with backslashes. Make sure the file is in the same directory as your Python script. Now, we'll actually open and read the CSV file. We use the with statement to ensure that the file is properly closed when we're done with it. Now, inside the with block, we use the CSV reader subfunction to create a reader object that allows us to read the file row by row. We're almost there. Now comes the exciting part, reading and processing the data. We'll use a for loop to iterate through each row in the CSV file. The reader object gives us each row as a list of values. We can simply print each row to see its contents. Inside the loop, we have access to each row as a list of values. You can perform various operations on this data. Now we will run this code and open the data inside the CSV file. There you have it. You've successfully written code to read data from a CSV file using pure Python. Make sure you have a CSV file named data.csv with some data and then run your script. Congratulations, you did it. You've learned how to read data from a CSV file step by step. CSV files are a great way to handle structured data in Python, and now you have the tools to work with them effectively. Now let's jump into another question. And the another question is, how can you check if a string contains only numeric characters using Python? All right. We'll be talking about how to check if a string contains only numeric characters using Python. It might sound a bit technical, but don't worry, we'll break it down step by step, and you'll have a clear understanding by the end of this topic. So let's dive right in. Okay, the first thing we need to do is create a function that will do the checking for us. Don't worry if you're new to functions. Think of them as little blocks of code that you can reuse. So let's type that out. Here, we've defined a function called is_numeric_string that takes one argument, str, which is the string we want to check. Inside the function, we're using a built-in method called isNumeric that Python provides for strings. This method returns true if all characters in the string are numeric and false otherwise. Great. Now that we have our function, let's put it to use. We'll provide a string to the function and it will tell us if the string contains only numeric characters. I am creating a variable called input string and assigning the value 1, 2, 3, 4, 5, which is a string containing only numbers. Then we call our is_numeric_string function with input string as the argument and store the result in the isNumeric variable, and finally we print the value of isNumeric. So, if the string contains only numeric characters, the function will return true and will see true printed. If not, it will return false and will see false printed. It's like a little truth detector for numeric strings. Let's run this code and see the result. And there you have it. You now know how to check if a string contains only numeric characters in Python. We defined a function, used a built-in method, and put it all together to get our answer. I hope this was helpful and that you enjoyed this step-by-step explanation. If you have any questions and suggestions, please do not hesitate to ask in the comments section. Now we will jump into another question. The next question is, write a Python function to transform a given date from one format to another. For example, from YMDD to MDY. All right, we're going to dive into a practical Python script that will help you transform dates from one format to another. Whether you're a seasoned programmer or just starting out, this step-by-step guide will make date conversion a breeze. So grab your coding gear and let's get started. Our first step is to import the datetime module, which will provide us with the tools we need to work with dates. Think of the datetime module as a toolbox filled with tools for manipulating dates. We're bringing in these tools to use later in our code. Next, let's define a Python function called transform_date that will take in 3 parameters. The date you want to convert, at date_str, the format it's currently in, from format, and the format you want to transform it into, to format. This function will help us convert dates from one format to another. Inside the function, we work some magic. We convert the string date to a datetime object using straptime, and then, with strophtime, we transform it into the desired format. Voila, a custom date transformation function is born. Here we're using the straptime method to parse the input date string and create a date object. Then, we use the streptime method to format the date object into the desired output format. This function is the heart of our code, and creating a variable called input date, and we're setting input date to August 14th, 2023, the date we want to transform. All right, now we need to transform the input date, August 14th, 2023, from the format YYYYMMDD to the format MMDDYYYY, and print the transformed date. Let's pull back the curtain and see the result of our date transformation. And there you have it, the moment of truth. We use print to display the transformed date variable, which holds the date after its breathtaking transformation. With just a few lines of code, we've created a handy function that can convert dates from one format to another. This can be incredibly useful when dealing with date data in your Python projects. Let's jump into another question. And the another question is, how can you calculate the difference between two dates in days using Python? Okay, we will see who we can calculate the difference between two dates in days using Python. This skill can come in handy for all sorts of tasks, from tracking events to managing project timelines. So let's jump right into it. All right, the first thing we need to do is import the module that will help us work with dates. In Python, it's called the datetime module. So import datetime module. Here, we're importing the datetime class from the datetime module. This class provides various methods to work with dates and times. Next, we're going to define two date strings that we want to calculate the difference between. Imagine these strings as the dates you'd write on a calendar. Here, I am creating two variables, date_str 1 inch and date_str 2, and assign the date strings, August 14th, 2023, and August 20th, 2023, to them. So Python doesn't inherently understand these strings as dates. So now we're going to convert these date strings into special objects called date-time objects. These objects allow us to perform calculations with dates easily. In this part, we use the strip time method to convert the date strings into date-time objects. The YYMMDD format represents year, month, and day in the string. All right, we're almost there. Now let's calculate the difference between the two dates. Here, we're subtracting date 1 inch from date 2 to get a date difference object, which represents the difference between the two dates. Last but not least, let's extract the number of days from the days difference object. We're using the dot days, attribute of the date difference object, to get the total number of days between the two dates. And now, the moment of truth. Let's display the calculated difference. Here, we're using the print function to show the result. We're simply printing out a message along with the days difference variable we calculated earlier. Now we will run this code and see the difference. And there you have it. We've successfully explained and walked through the process of calculating the difference between two dates using the datetime module in Python. I hope you found this explanation helpful. And if you have any questions or if there's something else you'd like to learn, feel free to leave a comment below. Now, we will see another question. So the next question is, write a Python function to validate if an email address is in the correct format. All right, we've got a handy script that's going to help you validate email addresses using Python. Whether you're building a registration system or just want to ensure your data is clean, this step-by-step tutorial will guide you through the process. So, let's dive into the world of email validation. Here we start off by importing module, re. The re module is crucial for working with regular expressions in Python. It provides functions to work with patterns and match strings. Next, we define a function called is_valid_email. That takes an email parameter. Inside the function, we have a variable called pattern. This variable holds the regular expression pattern that we'll use to validate the email. Here, caret and $, denote the start and end of the string, ensuring that the entire email matches the pattern. This W inside the square brackets matches one or more word characters, letters, digits, underscores, or dots or hyphens. This corresponds to the username part of the email. The @ sign matches the literal @ sign symbol. This pattern matches one or more word characters, followed by a dot, and then one or more word characters again. This corresponds to the domain name part of the email. This part matches a dot followed by one or more word characters. This corresponds to the top-level domain TLD part of the email. And the re-dot match of pattern. And email. Function checks if the email matches the pattern and is not. None checks if a match is found. If a match is found, the email is valid. Otherwise, it's not. Finally, we create a variable called email address and assign a valid email address, for example, alice@example.com. Then we call the is_valid_email function, passing in this email address. The result is stored in the is_valid variable. Finally, we use the print function to display whether the email is valid or not. Let's run this and see the result. And there you have it, folks. We've successfully broken down this Python script that validates email addresses using regular expressions. We've covered everything from importing modules to defining functions and utilizing regular expressions for pattern matching. That's it. Now we will jump into another question. And the next question is, how can Python's logging module contribute to effective ETL testing? Okay. All right, so ETL stands for extract, transform, load. It's like cleaning up and reshaping data so it's more useful. But testing all those steps can get tricky. That's where Python's logging module comes to the rescue. Meet our hero, Python's logging module. Think of it as a journal that your program keeps while it's doing ETL. It notes down all the important stuff, just like a diary. Look at this diary. It's writing down every move our program makes during ETL. When data is extracted, transformed, or loaded, it's all here. So you can keep track of what's happening. Uh-oh. Sometimes things don't go as planned. But no worries, the diary writes down warnings and errors too. It's like your early warning system, helping you find and fix issues. Now, let's adjust the diary's detail level. You can set it to show just the basics or give you all the nitty-gritty details. It's like having a superpower to focus on what's important. Ever wanted to know how much time each step takes or how many records you processed? Our diary collects all that info so you can analyze and improve your ETL process. Oh, and here's the cool part. You can write your own notes in the diary. Explain why something happened or what you're doing. It's like adding helpful comments to your code. And now we will have quick a look at the logging module code, how it's work in real time. In this code, we used basic config function to customize the format, set the log level, and even choose to save our logs in a file. Now, imagine we're working on a heroic ETL mission, transferring crucial data. With logging, we can be like spies watching every step of the journey, and Python's logging is like our very own Sherlock Holmes when it comes to debugging. It simulates if something goes wrong during data transformation. And that's a wrap, folks. You've just unlocked the immense power of Python's logging module for supercharging your ETL testing endeavors. It's like having a trusty sidekick documenting every step of your journey and helping you tackle unexpected twists. Let's dive into the grand finale, the final question. And the final question is, explain the role of data profiling in ETL testing and how Python can be utilized. All right, we're delving into the world of ETL testing and the powerful role of data profiling. Plus, we'll see how Python comes to the rescue for seamless data profiling. So, let's roll up our sleeves and dive right in. Before we jump into the coding magic, let's grasp the concept. Data profiling is like putting on your detective hat. We're analyzing our data to get a deep understanding of its quality, patterns, and distribution. It's like checking the ingredients of a recipe before cooking. Now imagine we're working on an ETL process. We're moving data from one place to another, and we want it to be flawless. That's where data profiling steps in. It ensures we catch any quirks or issues in the data before they lead to problems downstream. Let's have a look at one real-time example. Checking age data. Let's make this tangible with Python, shall we? Say we have a data set of customer ages. We want to make sure they fall within a reasonable range. Here's a Python script to do just that. Python allows us to swiftly identify any data anomalies. Look at this code snippet. We're using Python's pandas library to filter out ages that don't make sense. If we find any, we're notified instantly. Now we will run this code and see if there are any data anomalies in the CSV file. There you have it. We just found 2 data anomalies in the CSV file. And there you have it. Data profiling is like having a superhero's ability to catch data issues before they strike. Python acts as our trusty sidekick, automating checks and even performing transformations. This dynamic duo ensures smoother ETL testing. And as always, feel free to ask if you have any questions or suggestions in the comments section below. That's all, folks. Wrapping up. We've delved into a comprehensive array of 9 questions, all sourced from a recent interview at a big global company. But this is just the beginning. Brace yourselves for an influx of additional interview question sets heading our direction. Big thanks for hanging out with me today as we dived into the world of ETL testing using Python. If you found this tutorial helpful, I hope you did, a thumbs up and subscribing for more coding adventures would be awesome. Until next time, happy coding.